morning to one and all present here. Today I am going to be taking a small class on the topic equivalence relations. But before I just dive into the topic, I think we should brush up on our 11th concepts. That is going to be the base of today's class. But instead of just me explaining, let's have a rapid fire round. I'll just point at anybody and I'll have a very simple question that you have to answer. The first question is, what is sets? Does anyone want to voluntarily answer? Yeah.
Set is a collection of data.
A collection of?
Data.
Collection of?
Elements.
Elements. Okay. What is a subset? Dia. Oh, then just raise your hand so that I know that.
It's a part of the set.
Okay. Any more definitive answer to that?
Is the set collected from the main set?
Yeah. Okay. That's basically, you know what's the concept. What is a Cartesian product? Anybody? Or Cartesian product?
I guess not sure. Intersection of
Intersection? Oh, not exactly. So I understand that you are thorough with what set and subset is, but not basically what relations or Cartesian product is. So I'll just explain what that is. What is a relation? It is a subset of a Cartesian product. But since you all don't know what a Cartesian product is, I'll explain that first. Suppose this is set A and this is set B. These are two sets that are taken. Set A set A and set B. These are the elements of set A, B and C, and these are the elements of set B. From the word Cartesian product, you understand it's basically multiplication. So A cross B. That is, every element of A is connected to every element of B. That gives you another set. Let's say AB. No, A. No, let's take it as C. Set C is A1, A2, B1, B2, C1 and C2. This is a Cartesian product. Cartesian product is basically the multiplication of two sets, which gives you another set containing x, y elements such that x and y are elements from A and B respectively. That gives you an idea of what is a Cartesian product. Now, what is a relation? A relation is a subset of Cartesian product. Subsets are basically elements of another set, which are elements of a new set which already belong to a main set or a universal set. What is a relation? In other words, relation between two sets is defined as the collection of the ordered pair in which the ordered pair is formed by the object from each set. In this case, set A and set B. Now this brings us to another topic, types of relations. But before I go into the 12th grade topics, I'm again going back to 11th grade basics. That gives us three main types of sets. Universal set, universal relation. Second is the empty relation. And third is the identity relation. Is anybody familiar with these three terms? I mean, the word itself tells you what the relation is, but is anybody familiar what is an universal, empty and identity set? Okay, then I will be explaining that. Universal relation is basically a relation which contains all the elements of the Cartesian products. All the 6 elements that I wrote just now will be included in this universal set. It contains all the elements from the Cartesian product. It will have a relation such that all the elements A connecting B is also elements in universal set. Next is empty set. Empty set is null set. What is null set? It does not contain any elements. So what is an empty relation? A relation in which no elements of the Cartesian product is present. Basically a null relation. Next is an identity relation. Identity relation is in which it will be on A. Relation on set A. What does it mean, relation on set A? Relation on set A means that the relation is from set A to set A. Both the sets will be the same. Then this B set will not exist. It will be from A to A. And what is an identity set? It means A is related to A, B is related to B, and C is related to C. It is a set in which the elements are only elements that are connected or related to each other. For this set A, the identity relation will be of A, B, B, and C, C. That is the identity relation for this set. And okay, that I'll tell in the next step. This is basically what relation is. So I hope that you understand, so that the next topic is what is my main topic for today. Types of relation, but from the 12th point of view. Starting with reflexive relation. What is a reflexive relation? Before I go into the mathematical side, I want you to understand what does a reflexive mean. What is a reflection? A reflection. Okay, suppose you have a mirror and you're looking at it. What do you see? Yourself. That is reflexive relation, in which every element is related to itself. So the definition is relation of elements of a set A such that each element is related to itself. Even here, the difference between identity and reflexive. Now that's the question that majority of you will have, because I just told that identity is also when every element is related to itself. So then what makes reflexive different from identity relation? For an identity relation, the first difference is it should be on the same set. It should be from set A to set A. It cannot be between two different sets. Whereas in reflexive, it can be from set A to set B. All that matters is that the elements are related to itself. The next difference is for identity relation, the set should only contain A, B, B, C, C. It cannot contain any elements that is not related to itself. For example, you can't have an element C, D there. That is not then considered an identity relation. Whereas for reflexive relation, you can have A, B, B, C, C. Along with it, you can have your other elements like C, D, E, F, all of that. That is the main distinguishing factors between reflexive and identity relation. Now the condition, while solving question, you will be asked to write this. You will be asked to write this condition. If A, belongs to R, for every A belonging to set A, then R is said to be reflexive relation. If you do not write this condition, then half mark is gone. That's what my teacher told, so that's a trigger point for me. So now we'll go into examples so that you understand it properly. R equals x, y such that x and y works at the same organization or same place. So let me take two sample space or like sets A and B, and you have another A, B and C. Okay? So now this is set A, this is set B. This is A, this is the same person A here. This is B, the same person B here, but C is an extra in set B. Now what is the condition that we have here? That they work at the same place. If you work at the same place, do you think there can be a condition where you are not reflexive to like yourself. Like I study here in Indian school Seeb. So obviously in set B also, if I am there, I still study in Indian school Seeb. Does not mean I study in another school. So that gives us the relation denoted in capital R, A comma A, B comma B. This will be the reflexive relation for A and B. The next example we have is X and Y are parallel lines. We know the condition that every line is parallel to itself. That makes it related to each other. So if you have line L1 and L2 and L1 and L2, the reflexive relation or a relation connecting those two will be L1 L1 and L2 L2. That is a reflexive relation. I hope you understood. Now I'll be moving on to the next type of relation, which is symmetric relation. This is also very simple. From the word symmetry, you understand. It means, okay, this is your palm, right? Your palms. And you look at it, aren't they symmetric? From a very young class, you learn what symmetry is. It means that it looks the same, I guess, in a way. I forgot how, I'm forgetting how to explain it, but still, yes. For example, we have done this activity when we were in like primary schools, right? You take a paper, fold it in half, now you take a thread, put it in ink, and you put it on the paper. Then you close it, and you pull the thread out. And there's a design there, which is symmetric because the paper is folded. I hope you guys are understanding because from your facial expression, nothing is given out. Okay, thank you. Now the definition. The relation in which one element of the first set is related to another element of the second set. So A is related to B, like here. A, B is related to each other. Then the same element of the second set, which is B, is related to the same element of the first set. So it basically says that if A, B is related, then B and A should be related for the relation to be symmetric in nature. Now let me give you another examples for these as well. X and Y such that X and Y are biological brothers. Imagine they are brothers. If he is his brother, then obviously he is also his brother. That is what is known as symmetric relation. Like we have a set A, B, C, and we have another set, let's say C, B, A. B. Now our condition is that they are biological brothers. And we are given the, we are given with the sets in which it's given that A is B's brother and B is C's brother. So basically they are all brothers. So what will be your symmetric relation? A, B, B, C. Then you will also have C, B and B, A. There can be more elements. I'm just restricting it to these many elements. So do you see A, B exists in this set. B, A also exists in this set, and thus this relation can be classified as symmetric relation. Another example I've given is X and Y such that X and Y live 1 kilometer away from each other. If I live 1 kilometer away from you, means you also live 1 kilometer away from me. So you have the set A and B is also C and D. And I live 1 kilometer away from C and B lives 1 kilometer away from D. That gives you the relation A, C, B, D. But C also lives 1 kilometer away from me and D also lives 1 kilometer away from B, which makes you understand that C, A and D, B also exist in this relation. So here also A, C exists, C, A exists, B, D exists and D, B also exists. Thus it is a symmetric relation. And now the last one. This is a little bit confusing, but not that hard. Transitive relations. First, I'll just read out what the definition of the transitive relation is, and I'll give you an example for you to understand better. If the first element is related to the second element, and the second element is related to the third element of the set, then the first element must be related to the third element. So what does this mean? Let's say I have A, B, and C. A is related to B. B is related to C. But in order for this relation to be transitive, then A should also be related to C. To understand this better, let's take an example of three congruent triangles. A, B, and C. I have three congruent triangles A, B, and C. It is given that A is congruent to B. B is congruent to C. But we all studied it in 9th. If two triangles are congruent and the second triangle is congruent to a third triangle, then the first triangle is always congruent to the third triangle. Are you understanding what I am telling? So, if A is congruent to B and B is congruent to C, then obviously A and C are congruent to each other. This is a basic property of triangles that we use even today in physics and math. So if you understand this topic of congruency in triangles, then this is basically a piece of cake. To understand that much better, I'll give out the condition, which is important. If A and B related in R and B and C also belongs to R, then AC for all A, B, C belonging to A, then R is said to be a transitive relation. If in a relation, suppose you are given a relation in which A and B is there and B and C is there, and they have asked you if it is transitive, then the answer will be it's not transitive, because A and C does not exist in the relation. But in another case, if AB is given to you, but BC is not given to you, and then they have asked, is the relation transitive? Then according to math, you're supposed to say, yes, it is transitive, because you don't have other elements to prove that it is not transitive. If you cannot prove that a relation is not transitive, then the relation stands to be transitive. I'll give you an example for that as well. So, for R equals xy such that x and y study the same subjects. I study biology, my two other friends also study biology. So that gives us a relation. Me and my friend studies biology. My friend and my other friend also studies biology. But me and the other friend also study biology. But I study bio and one of my other friends studies English, let's say. So A and D. Now, this is the relation we have here. In a way, AB is there, BC is there, and A is also related to C, AC is also there. So R is transitive, right? But then this still remains. AD is there, but is there any other element containing D? There is no other element containing D. So if you were asked to prove that this set is not transitive, it is not possible. Do you know why? Because AD is there and there is no other element containing D. So it is impossible for you to prove that it is not transitive. So in a situation where you cannot prove that a relation is not transitive, it is considered to be transitive because you don't have the resources to prove it's transitive. That's another point. And the next example have the same mother tongue. It's all the same thing. It's just I've written it so that you can understand it with more real life examples and then mathematical examples. That brings us to my main topic, equivalence relations. A relation R on set A is said to be an equivalence relation only if the relation R is reflexive, symmetric, and transitive. If a relation has all these conditions, satisfies all these conditions, it is reflexive, which means all the elements are related to itself. If it's symmetric, if A related B, then B related A, And if it is transitive, if A related B, B related to C, and A related to C is also present in the relation, then it is an equivalence relation. I have an example for you to understand this better. R equals xy such that x and y are of the same gender. So let's start with the first condition, reflexive. Reflexive. This is set A and this is on set A, which means it's from set A to set A. A is, let's say, female, B is male, and C is again female. So obviously here also A is female, B is male, and C is female. Is it a reflexive relation? Let's see. A is female, obviously A is female. Related to each other, B is female, male, so B is again male. C is female, C is female. So every element of A is related to each other. Thus it is reflexive. Next is symmetric. Symmetric. Here A is related to A and A is also related to C. And C is related to C and C is also related to A. Thus, we can see that when A is related to C, C is also related to A. So, which brings us to the conclusion, it is symmetric as well. Then, it is transitive. A is related to C, C is related to A. But are they both related to each other? Is there another element connecting A and C? No. Thus, this is not a transitive relation. It's a reflexive relation, it's a symmetric relation, but it is not a transitive relation, and thus this relation will not be classified as an equivalence relation. Let's say we had one more person here who was a female. Let's say D, who is also a female. Then A is also related to D, D is related to itself, and C is also related to D. That brings us another element into the relation, which is A, D, C, D, which makes this relation transitive as well. Then this would be transitive, and thus it would be an equivalence relationship. That is the entire topic that I had to teach today. Summing it up, reflexive relation is when every element is related to itself. Symmetric is when two elements are related such that the second element is also related to the first element in the further condition. And then transitive is when A related to B, B related to C, and then C is related to A. And all of that summed together gives us an equivalence relations. So any questions? Yes.
Are all identity relations transitive?
Identity relations are not transitive. But yes, in a way it is, because we cannot prove it is not transitive, like I said. Because A, B, B, but we don't have another element where A is related to another, let's say, element of a given set. Anything else? Okay.
It's done? No more questions?
Alright.
Yes.
We took examples taking less number of elements.
Yeah.
To check. So what if there are like multiple elements, and for an exam point of view, is there any way to complete faster?
Yeah, even in your questions you have examples like A, B such that A cube is greater than B, let's say. And you have to prove that it's either transitive or an equivalence relationship, relation in total. In that, our teachers, to make it easier for us, they give you like points. Like for example, if it's for A cube is greater than B, they tell you to take A as 1, 2 and 3. I'll show you. A cube greater than B. So we have to prove that, let's say we have to prove it's not symmetric. It is not symmetric. So we take let A equals 1. I'm not sure. Yeah, I guess it's 1. Let A equals 10. Okay, let A equals 10. So then A cube equals 1000 and B equals 1. B is 1. This is one element which will give A, B equals 1000 by 1. But now to prove it is symmetric, you have to take the ulta of this. So it's b cube is 1 and a is still 10. But is that applicable to this? Yeah. So there will be something. I mean, the questions can't come very diverse. There are a set of questions that's given in the textbook or your guidebooks, and from within that, you will have some key points to take from. And yeah. So, yes.